All right, I think I got things figured out. Sorry, team. Folks can let me know if they can see and hear me okay in the live chat. Sorry for the glitch there. Not the world's greatest technology user. So hopefully this one is working okay. Everyone see and hear me okay? And we're back. Exactly. Thanks, Lisa. All right. J. Scott McLean says we're 5 by 5. So sorry. It's a little crazy with OBS because you hit go live, but there's a little bit of a lag. And I think I tapped it twice. So I like started the broadcast and ended it literally a second or so later. So many apologies for that. My degrees are in geology, earth science, and such, not so much in live streaming and technology. So, skill sets, learning as I go. Great. So, it looks like we're getting folks on board here. They have figured out the little glitch I had there. As always, thank you to our moderators. Susan and Lisa are here today as our moderators. Thank you so much for helping out. Our good friend Amanda Joe is up in North Iceland, taking some well-deserved time off and relaxing. It wouldn't surprise me if she jumped on at some point, but for now she's at least relaxing and enjoying herself. So yeah, if you can hit the like button, that's great. Anything you can do to help spread our geo learning community and make it better, that's always super helpful. We'll do a couple shout outs here. Apologize for a little bit of a late start here, but we'll get going pretty close to the top of the hour. We have Sandrine here from France. Thanks for joining us. Questions, if you could send questions with whatever format Susan and Lisa ask you to do those in. What we'll do here is a couple announcements at the beginning. I'll run through a brief update on Iceland, and then we will get to your questions, whatever questions you might have. Happy to have you here with us on a Saturday, kind of a cloudy, cooler day here in southern Idaho, a little bit of a reprieve from the heat that we've been having. So great that we have so many folks joining us today on their weekend. Let's see, we've got folks here from Bex from, I'm assuming that's North Carolina, NC. Kay from Dorset. Jerry from Finland. Yari from Finland. Zoe is watching from Portland. Awesome. Sue from the UK. Gary from Surrey, BC. Lots of folks here. Coming in fast and furious. Michelle from Switzerland. Ivana from Serbia. Oscar from San Diego. John in Ireland. Neil from Florida. Jane representing Texas. Very nice. Thanks for doing that. Yeah, Elaine from Tucson. She's on the mend. Marlies from Germany, where there's a thunderstorm. Susan's in north central Idaho. Ruth from Kilkenny, Ireland. Allison from Missouri. Great. Lots of folks here. We got folks from Europe, folks from North America. Haven't seen any of our down under friends yet, but we probably have some here. Of course, Lisa's here from New Zealand. Another Lisa from Nampa. Kim from Minnesota. Gary Ridgecrest. Mary Beth, New Mexico. All sorts of places. Jean from Fairbanks. So good to see all you folks here joining me today. So great, and the well wishes and the shout outs keep coming in, but I've got 1 o'clock here on my watch, and so I want to get things started and be very respectful of your time. I'll grab a couple notes here. Greetings and welcome. I am Geology Professor Shawn Willsey, coming to you live from southern Idaho, Twin Falls, Idaho to be specific. Thanks for joining me. We're going to do a live stream event here, broadcast, looking at some of the things that have taken place in Iceland. We'll answer your questions and answer. I have a few announcements right off the bat. It's about 1 p.m. here Mountain Daylight Time, 7 p.m. over in Iceland. And thanks for spending part of your Saturday with me. As many of you know, 2 days ago on August 22nd, we had our another eruption. I think that's number 6 or 7 for the year. I'd have to count them all up, but we've had the next eruption in this sequence that began back on December 18th of this past year. And this eruption was very similar to all the eruptions we've seen previously, but also a little bit different. And I want to go through some of the, I haven't heard a whole lot of analysis from the Met Office or other folks. We might get that in the coming week, but I think we can glean some of the information and some of the data that and the observations that we made while this was happening on Thursday and a little bit maybe yesterday on Friday. I think we can maybe take some of these observations and at least look at some of the differences and things moving forward. So let me start with some announcements though. First of all, I want to give a shout out to Isaac Finnbogason, who who's actually had his drone out and may still have his drone up right now. He has a great YouTube channel. He often has some of the best footage of these Icelandic eruptions I've seen, and he was generous enough to let me take a couple screenshots to show you. And the reason for that is, as we'll get to it here in a second, is the weather today in Iceland is not very conducive to watching the eruption on any of the webcams. It is smoky, it is windy, there are moss fires, that's why there's smoke, and then we have the volcanic gases. So those kind of things combined have conspired to make the viewing of the eruption from the available webcams not so ideal. Obviously, as we get later into the evening and it gets darker and you can see some of the incandescent glow coming from the lava, that will make things look a little bit better. But for now, I wanted to just use some of these really nice photos that he put together as sort of like the backdrop. So we're going to look at a couple photos. He was generous enough to allow me to take a few screenshots to show here. But let's start first things first. Just a couple quick announcements here in the way of the channel and the community. I do have an announcement here on my channel. It's right here. Nick Zentner and I, many of you are fans of him. He's another geologist and YouTube educator. He and I are actually going to be meeting up in the field in central Idaho on Saturday, September 7th, up at Stanley, Idaho, about 9 a.m. Now, there is a wildfire, a pretty strong wildfire up there right now that I'm very much aware of and very much paying attention to. So we're going to kind of monitor this moving forward. But 2 weeks is quite a bit of time. And with a little bit of luck and with the weather and our firefighting resources, hopefully that fire will be either under control or hopefully even out and we can proceed as planned. But for now, we're going to go ahead and plan that. So if you'd like to meet up with Nick and I out in the field in central Idaho, he and I are each going to do like a little half-hour, 40-minute kind of lecture there. You'll have the chance to meet other viewers. It's a great area to explore a little bit on your own. And so that announcement lives right there on my website. And then the other thing real quick is, or on my channel, on my website, there's also some field trips I have coming up. So if you're interested in getting out in the field with me and some other folks and just looking at rocks and interpreting landscapes and understanding more, there's a set of 3 field trips in northern Utah at the end of September, one up Little Cottonwood Canyon, one out at Antelope Island, and another one that runs from Ogden to the east to Echo Canyon, looking at evidence for a big mountain building event. We'll go from the guts of the mountain out to its proximal nearby deposits. Then there's another kind of round of field trips, and these are all individual, so you can just sign up for whichever days work for you. It's not a full package deal. Pretty simple. We all show up at a meeting place, do a little bit of orientation, carpool, drive around through the day, just bring a sack lunch, dress for the weather, pretty low key. There's a similar round of field trips here in southern Idaho in early October, the 11th, 12th, and 13th. You can see some of the locations there. This is a repeat of the ones I did in June. And then finally, there's 2 more dates, November 8th and 9th, right here around Twin Falls, looking at the Snake River Canyon and its geology, and then also looking at the role of lava and water just to the west of us in a little town called Hagerman. So those are just available for you. I understand many of you are in Europe and are too far away, but for those that can get here, this is a great opportunity. I'm hoping to sort of spread further abroad. Obviously, I'm not going to get everywhere. These field trips, I doubt there'll come a time where I'm, doing a 3-day field trip in Belarus or some really remote places. But for now, this is kind of what I'm doing to try to connect with folks and teach geology, which is my passion. So just announcements there about those sorts of things. Okay, let's move on to the eruption. So the eruption's continuing. We're on day 3 of the eruption. Let's maybe go to a map first. That might be a good place to start. And I think I'm going to go to this map, which I'm really fond of. I'll make sure this goes in the video description if you like this map. So this is just using aerial photographs, so we can see Grindavik down here at the southern edge. And then this is sort of the combined lava flows of all the prior eruptions, not including the one that started yesterday. So the imagery needed to put the lava flows from this past eruption are not on here just yet. But what we can see here is the extent of the lava field. Here's the power plant in the Blue Lagoon. And what's interesting about this eruption that occurred on Thursday is the southern end of the fissure system started right about more or less east of Silingerfeld, this hill right here, but then it went further north, even beyond the edge of, this is the December 18th lava field, and the fissure ends about right here. That was the furthest north fissure that we had, and this extended probably another kilometer or more north of that. And so we actually have a fissure system that's active right now. The most active part that's still erupting is up in this country right here. And these lava flows are moving to the east and the west, not really advancing a whole lot, and there hasn't been any lava flow activity impacting the roadway here, thankfully. So the great news about this eruption is that the way it played out, it presented no danger to the town. The lava flows were further north and really never advanced at all, or very little, to the south. So that really didn't put any sort of threat to the town itself. And although we did see some lava flows advancing to the west, and there was a period of time on Thursday night when it looked like we could be seeing some of those lava flows coming out here and potentially threatening the power plant in the Blue Lagoon. Those lavas ended up stalling before they got to the road here, and this set of fissures kind of died down a little bit, and the fissure system that picked up a little bit more was this system up here. And so with the primary activity focused in this area, this is a good place for a lot of lava to pile up. We've got a lot of open terrain over here to the east, up against these hills towards the Fagradalsfjall eruptions. There's some steeper topography over here. This is kind of a flat-ish area out here, but it's pretty vast and a pretty big area. And so the only real threat, even going into the next day, into Friday, was that would there be enough lava coming out of the system to get the flows coming over to the road here, and would they actually maybe make it all the way down the slope to the main road from the airport to Reykjavik. And as it stands right now, the output of the volcano is about 5%. That's one of the reports from the news outlets in Iceland. It's about 5% of what it was on Thursday when it began. So while it might still look impressive and it's still quite a spectacle, realize that its output of lava is greatly diminished over what we saw initially there on Thursday night. If it helps a little bit, we can also kind of look at, let me clean this up a little bit here. So here is my little Google Earth map. So here again is Grindavik, Blue Lagoon power plant here. And as best I can, I've delineated the location of the fissure system in green that is from this August 22nd eruption. But this part of the system to the south is pretty much over, and the most vigorous still erupting part is up here to the north. But when we compare that to the December eruption, you can see in the orange here where the December eruption was, more or less, and you can see that this last eruption here in August substantially lengthened by maybe a kilometer or so the fissure system further to the northeast here, and then you can see the lava field there associated with that. So it might be fun real quick just to run through the time sequence so we can just kind of see it all visually. And this is just my little Google Earth thing. The shape of the lava fields, those files have been sent from a viewer. And are they 100% spot on accurate? No, but they're really close, and so that's probably good enough for our purposes here. So here's our December eruption and the fissure system that fed those lavas. If we add the January one, of course, was the oddball, the anomaly of all these past 6 eruptions, I suppose. The one that was the most strange in terms of location was the January one because it was much further to the south. Not only did we have a fissure system break through the defensive berms, but we had a small, short-lived fissure system that popped up much further to the south, right near some homes that unfortunately we had 3 homes lost in that location. So there's our January extent of the lava field and the fissure system. When we get to February, which was the next eruption in the series, that was back up to the north, largely sort of mirroring or mimicking the conduits and the fissure systems that we saw with the December eruption. And you can see in red there the extent of that lava field. The big impact that we had from the February eruption was, of course, the lava flow disrupting and taking out the pipeline that supplied hot water and I think heat to some of the homes on the peninsula. And so folks in Iceland had a couple of rough days, at least a lot of folks did, while they were repairing that pipeline. If we look at the March 16th eruption, which is next and shown in blue, you can see again very close and similar to the location of the vents from the December and February eruption. Still sent a flow off to the west that was threatening, at least for a while, the Blue Lagoon and the power plant, but it did not didn't even really ride up to and abut, if you will, the defensive berms, these earthen structures that they had here. I think the biggest drama with the March eruption was this long continuous flow that came down to the south, and there was speculation at one point that this lava flow might continue to the southeast, head across the coastal road, and maybe go into the ocean. Certainly when we were monitoring that at the time, that was something we were looking at. So there's our March eruption. The next one was in May, and that's shown here kind of in green. I probably used 2 similar colors there. I need to probably change that. I don't have the fissure eruption mapped out here, but the primary vent is shown right here, nearly on top of this March event. So this was the May spatter cone that just kept going through a good chunk of June is right here. But you can see the extent of the flows here in May. This was the biggest one yet in terms of aerial distribution of lava. So it sent flows back again down to the west. We actually had a little bit of an overspill here that was problematic, and at the time they were spraying water on it near the power plant and doing all sorts of measures to try to control that flow. Luckily, the overspill happened kind of in the waning stages of this flow. You can see how expansive that was both to the west and the east, and there was several tongues of this thing that came down here, especially this big one here that came down to the southwest and actually took out part of this roadway, which has since been reestablished. The folks in Iceland are good at waiting a day or 2 and then getting the roadways reestablished. So that was our May eruption, and then of course we have our August 22nd eruption, which is shown here in the bright green. I don't have the lava field mapped yet. I'm sure we'll get something from the Met Office soon that shows that. So kind of a long-winded explanation, but that was hopefully helpful there as a bit of history of what we've been seeing in that area. Let's go back to yeah, we can get rid of these here. Let's go back to, yeah, the webcam's not really helpful, but you can see some of the red glow through the smoke. The lava has caused and ignited a lot of the moss in this area. So this is an area that has not had lava on top of the ground for hundreds of years. So it has developed a thick layer of moss on the surface covering the rocks below, and that's what's burning right now, and that's why the visibility is so low. We've got wind, we've got smoke from the moss fire, and then we just have the volcanic gases themselves. So most of the webcam views not super helpful. Even this one here, this is probably the best one, and it's not even that awesome. This one from the east, looking more or less to the west, so you're not getting the effects of the moss fires quite as much, but it's still at quite a distance there, but you can see a little bit of the fountaining going on there. Let me again take you to, let me open up one thing over here. I had this open earlier and I lost it. let me open up one. I want to go back to some of the photos that Isaac took with his drone today and show you just a couple of those so we can sort of see the nature of the eruption as it stands right now. I just took a couple of photos. I wanted to be very careful not to use too many of those. So I just grabbed 4 different photos that I want to show you. So let me pull those up. Bear with me for a second. Okay, here we go. So he was able to get closer with the drone. It was a tough fight with the high winds out of the north. The drone got down there pretty quick, but coming back was a struggle, and the location he had to launch from was further away than he normally is, and so it took some time to get out there. And by the time he got out there, there wasn't a whole lot of time for filming the eruption, so we had to do a lot of back and forth changing out the batteries. But we can see this northern section of the fissure system has now more or less concentrated, or it's starting to concentrate into specific segments, so it's not a continuous wall of erupting lava. There's discrete sections to it, and maybe if I skip ahead you can see that a little bit better here. So you can see there's a little section down here off to the left where there's a small little fissure system still erupting there, and then we just have these sort of point single location vents here. This one's a little bit more continuous on the right, but what we're seeing here is it's starting to wind down. What I'd expect to see most likely over the next 6, 12, maybe 24 hours is some of these smaller, less vigorous sections and vents that are erupting, probably those dying down, and then maybe 1 or 2 or 3 single locations that will start building an actual spatter cone. Right now we're not really building, we're building the foundation of a spatter cone, but it's not coming out of one single confined source. It's more of a linear distribution of lava here, so it's actually building up a ridge on either one or both sides of this fissure, and that's what we call a spatter rampart. And so you can kind of see, I think I've got a good view of it. Yeah, you can kind of see that right here. You can see this ridge of dark material here, the sort of discontinuous fissure system, and then just beyond it you can see where all this lava that's being jetted out of the ground is hitting, it's falling adjacent to the vent and then piling up. And on a circle back to that, I want to actually show you what this might look like on the ground. Like if I could take you there, if we could somehow put on our heat resistant suits, and if could just shut the lava down, what would this landscape look like? I want to show you just a few little scenes from Hawaii and a video I shot there that'll show you exactly what this might look like either years from now once this is cooled and solidified, or what it would look like if the lava had stopped erupting and it wasn't hot and dangerous, of course. So you can see it's sort of becoming, we had at one point in this eruption a 4-kilometer long fissure that's largely now confined to this much smaller area. So there's that small little section there that's kind of dying down. This section here, you can see that the flows or the vents are still sort of linked along this linear trend, so that you get a tongue of lava and this flow coming out the northeast end here, feeding these flow lobes. And if we look at actually that was a good view right there. If we look at the I guess the southwest end of this eruptive vent system, you can see this river of lava coming out here, which I guess is to the northwest. But nonetheless, these flows aren't really progressing very far. At least they're not advancing based on the output coming from these totally at this point. So yeah, so there's a view there. There's the lava kind of river coming out there. The view of all the vents, or that's probably most of them, looking more or less to the east. This is looking more or less to the south. You can see a lot of the smoke and haze, and of course the volcanic gases there, but there's that small set of vents, and then some over here. The smoke off in the distance, that's some of the moss fires. So these are the lava flows that poured out of these vents. The leading edge has started to incinerate and burn some of that moss that's out along the periphery, out in an area that wasn't covered with lava. So it's spreading. And then it's actually probably good that the winds out of the north, because the lavas are somewhat moving to the north, but the wind's kind of pushing the heat back the other way. So we're not getting the moss fires expanding off to the north. So anyway, just big shout out to Isaac for allowing me to use a couple of screenshots from his exceptional drone flights. I have a link to his YouTube channel in the video description. So anyone who wants to check out his stuff, whenever there's an eruption, he always does a great job documenting that. So thank you so much to him. Okay, so let's look at some of the data. Again, our view of the eruption as it's taking place right now is obviously hindered by the air quality. So there was one update from the Met Office today. Eruption seems to have stabilized. Activities all north of the hill Stora Stogafelt. No real seismic activity measured in the south. And they have dropped the alert level. They did evacuate, of course, the town, the Blue Lagoon. The Blue Lagoon, as I understand it, is back open already. And I'm assuming that they also have the town open to those who can go there. It's not open to the public, obviously. So it's stabilized. It's been fairly stable. It's confined to mainly that northern fissure. Lava flows mostly to the northwest, does not appear to be moving quickly, and the flow of lava towards Grindavik, the road that runs north-south out of Grindavik, seems to have stopped. Earthquakes are very low, so not a lot happening there. And with the winds out of the north, that's going to keep all that gas pushed towards Grindavik. So they might not have actually let people back into Grindavik with the winds the way they are. I'm not sure about that just yet. So there's that. If we go look at the earthquake data over the last 24 hours, that might look kind of ominous, but these are all pretty small earthquakes, and many of these are probably associated with the eruption that's ongoing there. So here's the power plant, Blue Lagoon over here. Here's Silingarfelt, Stora Stogafelt, and then here's this area, this northern fissure. That's where the eruptions are taking place. If we look at just the last, I don't know, maybe 10 hours or so, you can see it drop down. Last maybe 4 hours, just a couple of quakes in there, mostly pretty small. There's one magnitude 1 in there. So as we would expect, earthquakes kind of dying down, but of course when you're erupting magma, you're still going to generate some earthquakes, but there does not seem to be lengthening of the fissure system like we saw earlier. And speaking of that, let's move to this view of the earthquakes. I think this is pretty insightful here. So this is the past week. So this is from August 17th to August 24th, which is today. So Saturday to Saturday. And this nicely shows, real quick, the size of the circle is the magnitude of the quake. So the bigger the circle, like that one there's a big one. That's a magnitude 4.1. And then smaller ones are obviously smaller magnitudes. The color corresponds to how recent it is. So what you can sort of see here is, you know, a week ago, 5 days ago, that's going to be blue and green earthquakes. And so if you can sort of ignore the orange ones and just kind of look at the blue and green ones, you can kind of see them more or less evenly distributed from, I'd say about here, just east of Silingarfelt, and then sort of scattered around this area just north of the town. But no real rhyme or reason. You know, they're following a northeast-southwest trend, probably associated with the dike and maybe some other structures, those grabens that are in there, but not super concentrated in any given location. But what this nicely shows with these orange quakes here, these are all ones that were happening on Thursday, basically, Thursday or Friday. And so what you can see is even though the eruption began pretty much right about here, what it did is it lengthened to the northeast, forming that 4-kilometer long fissure system, and then it got even longer beyond that pretty quickly. And so it sort of unzippered to the northeast, which is interesting. You know, a lot of speculation prior to this eruption about the big crack at the south end of Hagafelt, all the big cracks running through town, and none of that really formed. I mean, and that's just what we see at the surface. So I think the important lesson here is a crack at the surface does not necessarily mean that it continues deep into the earth and can be a pathway for the lava to follow as it's migrating upwards. Clearly, whatever took place here 2 days ago, that magma, which was, you know, welling along this trend here, well, at least up to this point here, as it worked its way closer to the surface, it found pathways, easy, weak zones that it widened, reamed out, if you will, with magma as it propagated to the northeast. And we can see that that's what it did with these earthquakes. All of these earthquakes here, especially these bigger ones, these are all 2s and above, I believe. Yeah, there's a 2.2, 2s, 3s, and then we got the 1.4 over here. Most of these quakes are in response to the magma being injected into this region, the fractures being pushed apart, and as we're breaking rock, we're actually generating bigger earthquakes. And what I think might be going on here, this is just a hypothesis, shoot it down, whatever you want to do, is you might say to yourself, well, that's really weird because, we've got all these other conduits that it's taken, what about the January pathways? And what about all the stuff down in here? And what might be going on is those pathways still probably have magma in them, magma that's not completely cooled and solidified, but magma that has cooled off considerably. And when you have a spectrum of cold, brittle rock at one end of the spectrum and hot, molten magma at the other end of the spectrum, you can have a lot of different materials in between, and their resistancy, what's the right word I'm looking for? The force it takes to break those rocks can vary considerably. So what it looks like to me as a hypothesis is that it was easier for the magma to push to the northeast and break mostly cold, brittle rock, but rock that could be broken and be broken fairly easily with these earthquakes, than the magma following a path to the southwest where it would maybe have to break up partially solidified magma. Basically, magma, it's not completely rock, it's not completely magma, it's something in between. And sometimes when you're in that in-between zone, it doesn't break as easily, and it takes even more force to get the magma to break that material down or move through it. It's not hot enough to just remelt, and yet it's not cold enough to snap and break and behave brittly. So that's just an idea there. It'll be interesting to see if there's a little bit more research or anyone else that backs up that idea. But presumably it was easier to break unbroken, cold, brittle rock to the northeast than possibly reoccupy those same fractures that had partially solidified, partially cooled off magma down to the southwest, which perhaps bodes well. I mean, it's one eruption. Don't want to overanalyze it, but perhaps that bodes well for future eruptions, at least for this end, right? I think the big hazard now, as we start to, we'll enjoy this eruption. Thankfully, no infrastructure is at risk. This one looks like another bullet that's been dodged, but that gets me at least thinking about the next eruption, which could be weeks or months away, and where will it go? And, if it's several months away, will this material here be hard to break through? Will we still be able to break through further to the northeast? As we push if these earthquakes continue to push out to the northeast during the next event, that's bad news, because then we're starting to get lava field. While this is an uninhabited area, the primary piece of infrastructure here is the roadway from the airport to the capital area, and then the small town of Vogar, which sits right here. So while we might see future eruptions moving away from Grindavik, which is great, and away from the power plant, which is great, it does present a new set of hazards for a new area in Iceland. And so definitely not out of the woods, definitely something to think about. But this eruption did move further northeast than the prior eruptions, and occupied a set of ground in an area that we had not seen either with earthquakes really or with lava for the most part. So interesting stuff. Sorry for that, a little bit of a tangent there. If we look at the the GPS data, and probably the most helpful thing here will be to look at the 4-hour data. So if we go to our favorite station, the Svartsengi station, which we think sits more or less on top of or closest to the central point of uplift, what you can see here is the inflation going on through July and August, and then the big drop right here, that's the eruption. and we can already start to see it kind of starting to stabilize right here. Just a few data points. It's small sample size, so we're not going to get too carried away with this, but it looks like the deflation post eruption seems to be leveling out. And so we would expect, as this eruption starts to die down in terms of its volume output, as more magma moves into the system, we have no evidence whatsoever that the magma input from the deeper levels has stopped or is slowing down. And so I would expect over the next days and weeks this to start to trend back up, just like we've seen with all the prior eruptions. So the GPS data reflects what we've seen and come to know over the past over these past eruptions. Let's see, what else do I have for you? We looked at the map a little bit. We might use that again when we get to questions. And we are coming to you for questions here in a minute. Yeah, this was a news article that said that the lava output right now with this eruption is around 5% of what we saw on Thursday when it was at its peak, when it ripped open that 4, 6, 7 kilometer fissure, and it was just pumping out a tremendous amount of magma. But I think they go on to say that it turned out kind of as well as it could in terms of where it erupted and keeping the infrastructure at bay. The flow of lava towards the road seems to have stopped, and I really just like this because I had a great photo of the eruption there from a couple days ago. So another news article there, and then as I stated before, the Blue Lagoon is open. They're getting so good at this. I mean, literally, I think maybe it was less than 24 hours after the eruption. I think they might have been open yesterday even, which is pretty incredible. So, okay, so I think that is all I have for you for an update. I remember one more thing I have. I wanted to show you what the spatter ramparts look like up close. So, let me drag this over here. So what we have here, folks, is one of my videos. This is in Hawaii, and I wanted to show you that those great photos we saw of Isaac that show the fissure and the kind of hills and ridges of lava that are being coated and built up, what that would look like if you could actually get there, what it might look like once it's all cooled and solidified and you can explore it. So this is looking southeast. This is the Mauna Ulu area. So this eruption took place from 1969 to 1974, if I remember correctly. And what you're seeing here is this lava landscape. But what you're looking along here, this trend, this is the fissure system. There's actually a tree growing out of right along this fissure system. The fissure's partially filled in. So if you're saying to yourself, why am I not seeing a big continuous crack? Well, some of the lava that actually flowed away from this in the later stages when the fissure wasn't jetting lava out of the ground, some of that lava actually poured back down into the fissure, and you can actually see that with some of the flow lines here. But what I mainly want to focus on are these two kind of mounds of material on either side of the fissure, and these are what we call these spatter ramparts. So imagine lava being blasted up into the sky, just like we see in Iceland, and then that lava falls back down to the ground. And it's just like a cow pie of lava, and then another one falls on top of it, and all the while it's cooling, and so it's solidifying and it's building up the material that's going to become these spatter ramparts. So in this location, the eruption didn't last long enough or didn't concentrate into one location to form, in this location anyway, a proper spatter cone. So I'm going to kind of let this play with the sound down just so we can see a couple of different places here. So you have some folks there for scale. There's me yapping away using my hands to talk. And then let's see if we can just maybe scoot around. At one point here, I take you over to the spatter rampart so you can actually see what this material looks like. And it's just clots of lava. If you've watched some of my other videos, this is what we call agglutinate. This is just blobs of lava that have fallen out of the sky, stuck together. It's still molten, so you can still see a lot of the curvature of the topography as it's sort of dripping and oozing down the sides. Here's part of the fissure system right here where the tree's growing. There's me waving my hands, a couple of tourists. This is all in the national park. There you can see some of the drip features. So this very well could be something similar to what we would see if you could go out to that area in Iceland. In problem with what's happening in Iceland is it keeps erupting in more or less the same spots. But assuming it stopped and it didn't erupt again, this might be similar to what you would see in that area. I think here I just kind of like climb up onto the top of the spatter rampart. So now you're looking along the length of it. Most of it's on this side because of the wind. So this side's higher than what we see on the other side, primarily due to the wind. The wind was blowing in a certain direction. So now we're looking along the length of the fissure there. Some of it's filled in, some of it's not. And then there you go, some more of the spatter rampart. So I'll make sure there's a link to this video here in the description if you want to check this out in its entirety. But this would be a nice one to look at, right? This would be a nice comparison of what's the process happening now in Iceland and what would this landscape look like moving forward. So, and then what we have here in the background is the Mauna Ulu shield. So eventually at this site, in this area, the eruption became concentrated over here and it built up a large shield volcano, which is out here in the distance. So pretty cool. Just kind of a cool comparison. So as I was watching Isaac's drone footage, it made me think of that location and some of that terrain there. So awesome. So that being said, hopefully that was helpful, and we can then turn to the questions. And I knew it would happen, and it did. Amanda Joe's here. Awesome. I knew you would jump on. I'm like, well, I know she's got her thing, and she's supposed to be relaxing, but she's dedicated to the cause. What can I say? We're glad you're here, Amanda Joe. Great. So let me check my email and pull up the first round of questions that was sent to me by, oh, I guess we can leave these up, I suppose, from Susan. So thanks for sending your questions. We'll do at least 2 rounds of questions. We'll see how it goes. We do have, it's not for a while now, but we do have a wedding reception to get to later. We're finally getting to the age where like all our friends that are our age, this is the first child of any of our kind of friend group that's getting married. So we're kind of going into that stage of life. Okay, from Siegel, can you tell me why the fissure didn't extend south this time but north? Lava would need least resistance zones like in south as the crust got weakened there too much, but it went north with stronger crust. Yeah, I think I kind of addressed that. And again, I don't know per se, but I think there's something to my notion as a structural geologist. It's easier to break cold, brittle rock than slightly warmer. I mean, if it's completely melted, then it's easy, right? It's molten magma. But I think what we're seeing is that these older eruptions and these structures down here, at least in terms of the dike, right? It's actually where this magma re-injects itself. It's harder to break through possibly that material there. All we know is that the magma is going to take the path of least resistance, and in this case, it found an easier pathway out to the north. So yeah, that's a great question. I wish I had like a really strong, concrete answer there, but I don't. So that's my hypothesis. It'll be neat to see if someone does a little bit of research on that. From Natasha, Anna, is it known how much lava has come out in this eruption? Is it more than the previous ones? I haven't seen any numbers yet, so I don't know. That being said, it feels lower. It seems lower than, feels is the wrong word. It seems lower than the May eruption and maybe even the March eruption. So there's not a volume estimate yet, although I bet that's coming soon. And the other estimate we might see would be an area estimate, right? So we want to see how much lava cover, how much of the ground did the lava cover, and then we also want to see an estimate of what the volume of lava is, and that would take into account not just the area that it covered, but how thick it is. So those are really good questions, I think, because the eruption is still ongoing, but not quite over, and so recent we haven't seen any numbers yet. But I would expect to get some estimates from the Met Office or other places this coming week. Jeffrey Porter, have lab sample results from either of the past two eruptions come out in a paper? Not that I know, Jeffrey Porter. I don't know. I'm assuming you're talking about when they go and get samples of the lava and do the geochemistry on it. I don't think that's happened. I'm sure the samples have been taken. I don't think the results have been published. So they're probably still doing the analyses of those samples. From Ethan Simeon, is this eruption occurring at the same location where the Eurasian and North American plates are separating from each other? Yeah, more or less, but let's remember that a plate boundary is a zone. It's not a line. So the plate boundary coming through the Reykjanes Peninsula has segments, and it's a zone. And you can actually see over here to some degree how wide the zone is. You can see all these fractures and lines over here. This is more or less the northwest edge of the plate boundary. So this is for sure the North American plate over here at the top left. But from here all the way over to about here, this is the other side of the plate boundary. So the plate boundary is literally this 5 kilometer zone of structures. It's not just one crack running through the ground. It's a series of structures, faults, fractures that allow movement of the plates. So over here, definitely, Eurasian plate. Over here, definitely North American plate. But in between, this is the zone. And that zone comes up through here. But then it kind of takes an offset, and then there's another segment that kind of comes through here. Then there's another one over here at the Krishevik system. The Fagradalsfjall area is kind of a weird one. I don't think most geologists would put this as a segmented boundary. I think what the last paper from Val Troll and some others suggested is that the eruptions here in 2021 to 2023 were coming from a deeper magma source straight, more or less, up to the surface, and not really following pre-existing fracture and fissure and vent systems like we've seen over here. Yeah, hopefully that's a satisfying answer there. 3D modeler from Rotterdam. I count the seconds a piece of lava from a fountain takes to hit the ground. I can calculate the height. What is the formula? Oh boy, I just saw that. Someone posted that today. I don't know off the top of my head. I'm sure someone in the live chat might know, though. I bet we can get an answer from our smart community on the live chat. It's something like for every second, you watch it when it gets to its apex and starts to fall, and every second it's in the air equals a certain distance, as just sort of a rough way to estimate the height of the fountain. So I don't have that on the tip of my tongue, but I bet someone else does. Susie Jones, did the magnitude 4 earthquake shake the system up mid-eruption? So do you think there was a northern intrusion as well? I think I understand the question. Let's go here. So the magnitude 4, is that it right there? Yeah, that one's weird because it's not where the magma is pushing. So this one will be interesting to look at because it's a good size earthquake. People felt it, I heard, in the capital area and in other regions. But it's not over here where the eruption ended up being. So it's possible that the stress of the magma injecting into those pre-existing fractures as the magma was pushing up and to the north, that you maybe had another older fault system over here that reached its critical threshold point of failure and then broke and generated this magnitude 4 quake. So I don't think so. Is it related to the magma intrusion? Well, it is in terms of time, right? These are all taking place on the same day or so, but it's not in line with where we see the magma being injected. And so, I think it's the stress of the magma pushing up that generates some of these farther afield earthquakes. So they're not directly they are related to the magma injection, but they're not at the site of the magma injection is maybe the best way I could describe it. Okay, Paul H. Does cooled lava ever break down to such a state that it resembles something like the soil we get in the garden, or does it stay rock-like? No, absolutely. Any rock is susceptible to, over time, breaking down into small pieces, and there's a number of weathering processes that accompany that, and can be freeze-thaw cycles in the rock. It can be, if you're on a coastline or there's salt involved, you can get the salt crystallizing and breaking the rock up. It could be chemical processes. A number of things can break the rock down into pieces. Certainly, if you're in a wetter climate and generally a warmer climate, it's going to be more rapid, the rate of weathering. So in the tropical regions, weathering is pretty much at its highest rate. And so it does break down eventually into soils. And I've been told, I don't know the chemistry of this per se, but volcanic soils in particular, over time, tend to be very productive. And so you can grow a lot of crops or vegetables or whatever in those volcanic soils. So yes, absolutely, cooled lava eventually does break down, but it can take, in dry places like where I live here in southern Idaho, we have lava flows out in the desert that look almost as fresh as the Iceland ones, but they're 2,000 years old. And there's very little soil development, and the rock is still there. The lava looks like it did more or less the day after it erupted. And then you go to a place like Hawaii, to some, well, Iceland's a little different, but Hawaii or a tropical location, and that same lava flow can break down into soil and start growing plants within maybe just 100 or 200 years. So it just depends on the climate. That's a big factor there. Chris Morrison, is there a reason the eruptions have all been to the north and the fissures near Grindavik haven't opened up again? Yeah, so I touched on that a little bit. I don't know. I don't know for sure what the answer is. I think my rationale and some of my reasoning here is valid. I think there's something to it. Could it be something else? Absolutely. So we busted up a lot of ground here with earthquakes, and we know we have lava that goes at least as far south, or we did have the magma come out down here for the January eruption. And even in the last eruption prior in May, there was, I think there was those cracks in Hagafelt, and some of those things took place. But for whatever reason, the magma pathway was to take that magma storage out of storage, which is underneath this area here, moving it up towards the surface. I know this is not helpful because we're not looking at it in 3D view, but then that magma was preferentially moved to the north because that was where the weakest rock was. And my contention, right or wrong, is that perhaps these rocks being cooler and more brittle provided an easier pathway for that magma to move rather than moving to the south, where there's obviously, there's still probably magma in some of those fractures. Maybe the fractures aren't as open. Maybe up here you have in the subsurface more open fractures that are, even if it's just open a few centimeters, and you can inject the magma into that, and you've got all the pressure of the magma, and as it rises, the gases are trying to come out and expand. That will force the rock open even more. That will generate your earthquakes. Now you've got more space, and it's almost like a runaway domino effect to some degree. If you can link up enough of these fractures and move it, in this case, to the north and up, you might be able to get it move in the way that we saw this past week. Dan Cooper, did all these recent earthquakes cause additional damage in Grindavik? Not that I've heard, Dan. Maybe Amanda Joe could jump on. My guess is these quakes were, even that 4 up there, probably not strong enough to generate substantial damage. But that being said, there's already things kind of teetering and big cracks in the ground down here. So possible that there was a little bit of damage in the town. But I haven't heard anything reported as of yet. So, yeah, really good question there. I'd be interested to know that as well. All right, one more set of questions. Thanks to Susan for sending those, and thanks to Lisa and Amanda Joe for helping out in the chat too. From Maro, was there any seismic activity in this current eruption area when this all started happening? Yeah, we definitely saw the quakes, and this was the fun story I told on Thursday as I was getting ready to do. We could probably do. Well, I'd have to figure out the times. I don't want to do that on the fly, but you could probably go to this website and select time frames, 1 hour time frames on the 22nd and see this happening. I guess it started at what, 9:30? So let's look at like that would be 7:30. All right, we're doing this on the fly. I just decided it. But there absolutely was a flurry of earthquakes or uptick of earthquakes that took place during that. So, okay, maybe this will prove me a big fat liar. Do I have the right dates there? Yeah, August 22nd, 7:30 to 8:30. Not one earthquake. What about from 8:30 to 9:30? All right, there you go. So literally, if the data and the way I'm doing this is right, no earthquakes, the calm before the storm, if you will, from 8:30 to 9:30, and then there were, how many earthquakes do we have here? 38 earthquakes within an hour period concentrated in this area. There's where the vent opens up just east of Siddingerfeld, and there's where it eventually lengthens to up here by Stora Stogafeld. And so this, along with the borehole changes at the power plant, is what prompted the evacuation of the town, the Blue Lagoon, and the power plant. So they got ahead of it with the earthquakes and the borehole changes about a half an hour before it all started. And I was in my office getting ready to just do a regular ho-hum Iceland update because it had been a few days. And I saw the alert that they had evacuated the town. I quickly looked at the seismic data. I don't have access to the borehole data, and that's when I was scrambling trying to figure out what to do. I'm like, do I do a regular update? Do I do a live stream? How do I get this put together? So I decided to do a live stream. I started to put together the thumbnail and all the silly things you have to do to get a live stream going, and I had the webcam up and got to see the eruption begin. And then I think I was live streaming it within just a few minutes of it starting, which was cool and very exciting. So yeah, to answer your question, absolutely. The ones to the north, though, those took a little bit longer. So the earthquakes that we now see up here, because eruption is now up in this area, those would come in a little bit later. So now if we went from, let's say, 9:30 to 10:30. Now they've moved further north. This is actually great. This is fun analysis. Are you guys having fun with this? All right, this is good stuff. All right, so we just saw what the earthquakes looked like from 8:30 to 9:30. Okay, there was a bunch down here by Siddingerfeld, and then a few here. The next hour, here's your distribution of earthquakes. Okay, concentrated near Stora Stogafeld, but now starting to spread out to the northeast. And then if we look at the next hour from 10:30 to 11:30 local time. Oh, this is so cool. Like you can just see them moving, right? They're just migrating up there. The whole thing is just opening up like a pair of scissors or a zipper, whatever your analogy is there. And the stress field around that propagating tip, that magma dike has a tip to it, both vertically and to the northeast, and it's forcing its way to the northeast. It's trying to push in that direction, and as that force is generating stress in the region around it, and that's being manifested by these earthquakes, including, there's your big magnitude 4 that took place there. So, oh my gosh, I'm having a lot of fun now. So now let's go, okay, now I got to go to the next date. So now let's go from 11:30 to 12:30 at night on that date. And now that's when that fissure opens up. Now things are concentrated because now instead of the stress field being ahead of the propagating tip, it's actually pushing up. It's found a conduit to the surface, and there's your fissure that is erupting right now, even as we speak. Fantastic. I'm gonna have to play with that and maybe that would have been nice if I was doing a presentation, just those 4 little diagrams in a row would be very neat. Is anyone else feeling like this hair is standing up on the back of my neck? This was really fun. All right, let's do one more time frame just because I want to see what it looked like the next hour, and then I'll stop this little rant on this because I know there's other questions. But I'm just interested to see. Yeah, and then it's just sort of concentrated in that area. But I do remember it does seem like there was a time when they did spread out a little further to the northeast. Yeah, there's some more. Okay, so I'll play with this, but I think I showed you pretty nicely there with 4 or 5 um, shots there in a row, 1 hour increments of data, the propagation and the movement of the earthquakes, which are indicative of the pathway of the magma. That's why when we get that close, we watch the GPS in between eruptions, we watch the uplift, but in those hours before and even during, in this case, the eruption, the earthquakes are the things to watch. The earthquakes are the things to keep track of. That's showing you to some degree where the magma is going, where it's going to come up. The earthquakes nicely showed us exactly where the magma was going to start erupting, just east of Sidingerfeld. And then the earthquakes nicely showed us where the magma moved. And that's why this specific eruption was different from the other ones, primarily because while all of them showed a nice opening of a fissure, typically we hadn't seen it break open and produce the kind of earthquake activity we saw with this one. And that tells us it was breaking, and with the size of the earthquakes too, I think it was breaking definitely some older, colder, more brittle rock to the northeast. Very cool stuff. Okay, back to the question. Sorry, I got excited there. It happens. Can you show the graphs for more northern GPS station? Sure. Let's see. I know a couple ways to do it. Let's just see if we can pick. Actually, the best way to do that might be this. Is this the one I want? No, that's not what I want. Wrong spot. Is it this one? I can't remember. I've got so many tabs now. Let's try this one. Yeah, it would be neat to see the further northeast GPS stations to see, and this might even have it too. Does this have GPS on it? No, I don't think so. No, this is just a different map. Well, that site's not opening up. Maybe I can't. Play around. Maybe you can find that. Sorry. Seagull, what is happening with the current GPS data and seismometers in Grindavik? Are there any signs of activity? Well, we saw earthquakes. Nothing happening with earthquakes. GPS data, I have not really checked and given that a hard look. Best guess, I mean, we can sort of look at the. Oh, now this one is loaded. Let's see. I haven't played with this one as much. That's a pretty good location there. Let's take this one first. So this is showing, is it just a single point per day? That kind of sucks. So it moved up. So this station vertically moved up, it moved to the west, and it moved to the north. So it moved northwest and up at this specific location right here. So, and that was this station right here. Makes sense that it's moving northwest. It's moving away because it's on the northwest side of the fissure system that opened up, right, which is over here. What's cool about this map is it actually shows with these yellow lines these pre-existing fractures and faults, and so these are the pathways the magma was more or less following. And this one here and that little offset section there look like those line up pretty good, at least just eyeballing it with where this thing actually ended up erupting with this further northeast section. So anyway, I'll put this site in the video description too, and you can play around with it. You can go to all the blue dots. Those are GPS stations. You can check out the data, so we're not belaboring it a little too much. Diane Pedersen, does all this reporting on the eruptions rekindle any fieldwork, research, or theses possibilities you'd like to work on? Yeah, fun stuff. I mean, right now I'm very passionately involved with just the not so much the research, the boots on the ground research, but more understanding it and then conveying that to the public. That being said, if someone came to me and said, "Hey, we're working on this, this project in Iceland. Would you like to be part of the team?" Depending on the project, I would jump at that chance. So, in terms of starting something up on my own and getting grant funding and writing proposals, and probably not going to do that anytime soon. But yeah, thanks for your question. Linda Archinal, did the groundwater get warmer over the magma chamber? Why wasn't that area a concern for eruption? The groundwater is warmer over the magma chamber because we have the Svartsengi power plant in the Blue Lagoon. But the groundwater system is at a fairly shallow level as opposed to the deeper seated magma storage zone, which sits down like 5 kilometers. The hot water that they're tapping there is within the upper kilometer or so of the surface. And we're not too worried. There's groundwater kind of everywhere on the Reykjanes Peninsula and everywhere on land in Iceland, really. We're not worried with it getting mixing with the magma. It depends on the proportions. If you have equal amounts water and magma, then that could be a little bit more explosive. If you just have, you know, less groundwater and this incredible amount of magma, that magma tends to kind of override that groundwater signature. Although when it gets in the shallow level, sometimes it can be a little bit more of a concern. Brian Savage, is this a normal quantity of eruptions for this particular area, or is this an abnormal quantity of eruptions for this particular area? Well, if you're talking about just like, you know, the eruption that began on Thursday and comparing it to the other eruptions this year and in December, yeah, it's pretty normal. Like this is, you know, those of us that have been following this since last fall, this is exciting. This is awesome. But, you know, we've also seen this happen 4, 5, 6 times already. And so it is somewhat normal, if that's the right word for it. So it's a normal amount of lava that we've seen so far. It doesn't seem to be anything out of the ordinary or off trend of what we've seen so far. Okay, let's do, I think this will do this as the last question from Charlotte Rose. If the volume released is less than the previous eruptions, why has the ground level dropped back to the same level as it was just after the last eruption? Happy to be educated. Well, I'm also happy to be educated. Learning is fun. The volume released is less than the previous eruptions. Well, so even if it's less than the previous eruptions, the ground inflates as the magma accumulates. A lot of that is gas though, but it's dissolved gas, so it's not really expanding. Then once it makes its way to the surface, the gases come out of solution. They can jet that lava up to the surface there, and you release some amount of lava from the system. Not all of that magma gets erupted, and then you get some deflation that goes along with that. And you might get some extra dropping of the ground level if you put lava on top of that location. So if now this wouldn't make sense because you'd probably lose your GPS station, but if you put 10 feet of dense basaltic lava on top of an area, that's very dense, heavy rock, and so that can actually cause it to sink back down a little bit. And it doesn't sink back down to the same level because we think there's expansion of the magma. It's creating a little bit more space. It's probably starting to make the rock around it a little bit warmer, and so it's a little bit more expansive and such. So, okay, so hopefully that is a helpful answer. Looking at the live chat now, looks like you guys are doing good things there. Any thoughts or questions that I might have missed? Looks like some of you are just answering stuff for me, which is great because we're all here to learn together. I am not the expert of everything. And I think I got 2 pages of questions there, so that's pretty sweet. Excellent. Anything else? Well, this was fun. Yeah, we did this for about an hour or so. It's probably good for a Saturday, right? Let's check the I'm assuming we're not going to see much with the webcams. Yeah, there you go. Some red through the moss fire smoke and the wind and such. So not much to see, but the glow's showing up a little better. It looks like it's closer to dusk there in Iceland. You can kind of see that on that photo there or that video there. And so we are getting closer to a period of time when the lava is going to show up a little bit better. I love this camera. I just love because it's, nature's just on display right here, and then at the bottom you've got the cars just kind of like driving back and forth. I mean, only in Iceland, right? I mean, it's not only in Iceland, but just all right, just gotta get the DoorDash delivery somewhere, and oh no, there's a lava erupting just outside my driver's side window. Very cool. So we'll keep track of this moving forward, team. And what we expect, of course, is for the eruption to continue for some number of days, possibly just a few days, possibly a few weeks. Doesn't look like the lava flows are going to advance much further, although this is still a dynamic situation. There still could be, some movement. Remember that topography is weird. These eruptions create their own topography. So still not time to totally just turn the page on this and put your guard down completely. Let's also make a big public service announcement to help the economy of Iceland. And here it is, a U.S. geologist who knows about Iceland's volcanoes telling you, one and all, and I know I'm preaching to the choir, that Iceland is completely safe to travel to, that even though there is an actively erupting volcano probably 10, 12 kilometers from an international airport, this is a fairly well-behaved eruption. It's not threatening any infrastructure. It's not impacting air traffic. It's not really impacting air quality to any area of note, and that 99% of Iceland is completely unaffected by this. So this is affecting one little small part of Iceland. It is not the reason to, change your travel plans. If anyone wants to give me their ticket to Iceland because they are concerned about what's happening right there, I will gladly take that and I will go there. So there you go. Fun stuff. Okay, so we'll go ahead and wrap up then. Thank you all for joining me on the Saturday, whether it's afternoon or evening, or possibly a Sunday if you're in the other side of the globe. We will do some more of these moving forward. Not sure what this next week's schedule looks like. I'm back in the office. Please go to my website, willseygeology.com, if you're interested in any of the field trips that are coming up. I'll put the link to the Hawaii video so you guys can watch and see what the spatter ramparts kind of look like and see one from about 60, 50 years ago over there in Hawaii. But we will convene together here at some future date. Thank you all for joining. Thanks again to our moderators, Lisa, Amanda, Joe, and Susan, for the great work they do. Please give them a quick shout out as well. And we will see you all next time. Thanks so much. Be well.